Hello, I'm Alex Nugent, inventor of AHA Computing. Now, the first step in turning AHA Computing from a theory into real physical learning processors was to obtain a new type of device called a Memristor. Well, we've done that, and now that it's entering production, we're moving on to the next step. And that involves a range of tasks, from simulation of memristors and circuits, all the way up to the design and utilization of high-performance computing systems. And that's why I'm extremely excited to introduce to you Dr. Dhireesha Kudithipudi.
I'm Dhireesha Kudithipudi. I'm a computer engineer by training, primarily a digital system designer. My long-term vision is to build intelligent and energy-efficient systems that have long-lasting societal impact. Not only optimizing them by looking at conventional techniques, but looking at inspirations outside the field, looking more at interdisciplinary and transdisciplinary collaborations that would help us to bring more energy-efficient solutions to these computing systems. So while we were looking at different energy-efficient technologies, I think we were really inspired by the human brain in the sense that it is extremely energy-efficient, robust, resilient, and very good in decision making most of the times. So we were looking at ways to abstract the operating principles of this brain onto hardware systems so that they're inherently energy efficient but also have these capabilities to do intelligent information processing.
Brains have evolved to solve a very different problem than what computers were designed to do. Computers calculate. They perform mathematical equations or steps. And aside from somebody, a human, telling them what to do, they're pretty dumb.
They are number crunching systems. They are really good at crunching numbers. They are not very good at decision making or anomaly detection or pattern matching or classification kind of tasks.
If we want to solve the types of problems that we're interested in now, like machine learning or anything that involves lots of interaction and adaptation, we need something radically different.
You need a different computing paradigm that can efficiently process this kind of information.
AHA Computing has taken the idea that a brain is a self-organized system and said, well, let's look at simpler systems in nature that also display self-organization, and let's see where the overlap is. And it turns out there is an overlap. There is a fundamental adaptive building block that is at the heart of self-organization across nature. Well, we can mimic that. We can take that building block or process and we can put it into our electronics. And the way that we do that is by utilizing this new adaptive device called a Memristor.
We are looking at a new generation of computing systems, and in order to do that, you need to find creative ways in performing the computation itself. Memristor is a technology that enables us to reduce this energy dissipation anywhere from the order of 5 to 10 orders, depending on how we are using these devices.
When we talk about increasing the energy efficiency of computing systems, and we say things like 5 to 10 orders, what we're really saying is 100,000 to 10 billion-fold reduction in the amount of energy that these systems dissipate. This is like going from a nuclear power plant down to a AA battery. This is massive. We can now take what would consume a whole data center and shrink it down into something that can fit on a cell phone or on a portable platform. We're talking about increasing the capabilities of a wide range of systems and enabling new things that have not existed before. There's a curious and certainly frustrating problem when you're trying to build a fundamentally new type of processor. And that is that you need processors to design the applications, but you can't design the applications unless you have the processors. And after a while, we realized that the solution was that you do both at the same time. And so what we're doing is starting two parallel tracks. tracks. So on the one hand, we have our chip design track, thermodynamic RAM, and on the other hand, we have our application platform, the Sense server. So Sense server enters the market first with emulations of thermodynamic RAM. And in that way, we get feedback from our application developers and our clients solving real-world problems. And that feedback goes to circuit designers like Dr. K and her team at RIT in order to optimize the processors. So when the chips are built, they fit seamlessly into the application platform.
To build a system of this scale, you need scientists from these different disciplines actively collaborating. So that's what is happening here. Dr. Campbell is fabricating the devices, and our role is to help Alex design efficient circuits and estimate the energy efficiency of these circuits and provide techniques and ways to optimize for energy in these systems, and to also give a pragmatic layout design that could be put onto silicon. We also want to emulate the behavior of the system on different hardware platforms. So the second aspect of the project that we are helping him with is actually porting onto these different boards, and one board is the paralleler. You could almost think of it as a small supercomputer in your hand, and we currently are also looking at porting some of it onto FPGA platforms. So what's exciting about Alex's approach is that he has taken inspiration from nature to build a theoretical framework, but now it's a pragmatic solution.
A lot of people say they want to change the world. I want to help people solve problems in a changing world. To say that this has been an exciting and productive year would be a total understatement. Along with Knowm partner Tim Moulter, we published The Theory of AHA Computing in an international open access journal. We've secured a production line of Memristors with development partner Dr. Chris Campbell. And now we have built the application development platform, the Sense server, with Dr. Dhireesha Kudithipudi. Now we would like to partner with you. Whether you are an application developer or just have an idea for an application, it's your feedback that will help us optimize and finalize the design of thermodynamic RAM so that we can bring this technology to life.